2015. But this year, our conservation coordinator, Drew Potter, who's hiding in the back there, and Marshall Wolf, who will be talking tonight, really took that to the next level by installing not one or two Beaver Dam Analogs, but a dozen out of the Nature Preserve, and along with that, a significant amount of monitoring equipment, so that we can really learn in detail about how these are impacting the Nature Preserve, and then we can share that information with our community, with our city, with our region, so that other people can benefit from that as well. So Marshall Wolf is a PhD student studying aquatic ecology in the Department of Watershed Science and the Ecology Center at Utah State University. Before returning to graduate school, he worked at a variety of institutions throughout the American West. Prior to joining USU, he worked for UC Berkeley's Eel River Critical Zone Observatory on a project studying nutrient cycling and groundwater dynamics in the redwood forests of coastal California. His interest in understanding the role of beavers in structuring ecosystems was first sparked while working for the Oregon Department of Fish and Wildlife as a stream surveyor in the Rouge River Basin. During his free time, Marshall enjoys mountain biking, split boarding, and also skiing the Beaver at Cache Valley's Beaver Mountains in the area. And so just a couple of logistics before I pass it over to Marshall. He'll be speaking for about 45 minutes, and then we'll have 10 or 15 minutes for questions. So please hold most of your questions unless it's just a quick clarification until the end of the talk. And he has also generously offered to stick around for a while afterwards if people want to chat with him one-on-one. And then I have to say, if you feel inspired to help with a project like this or another land restoration project, you can always sign up to volunteer at our front desk on your way out. So with that, I'll pass it to Maria.
Alrighty, thanks y'all for coming. It's really exciting to see this many smiling faces. We're excited about our project here at Swaner, and I'm just excited to tell you all about it. Before I get started, I just kind of want to give a shout out to our funders, particularly Swaner for actually acquiring the money to get this project done and do the monitoring, Utah State for funding me and paying me to do this cool project, and then particularly Wild Utah helped us get tons of volunteers, literally hundreds of hours donated of time to actually install these BDAs, and the Utah Department of Environmental Quality gave us a substantial grant to buy monitoring equipment and actually wooden posts and such to build these BDAs. So I guess this won't work. Next.
Oh no. Okay, I'll get the charger. Try now.
Oh, there we go. Sweet. Okay. So I guess just a quick overview of what this talk is going to be about. Essentially, I'm going to kind of give you an introduction to what the BDA, the Beaver Dam Analog project here at Swaner, is trying to achieve, explain why we're using them and how we expect them to impact the ecosystem here on East Canyon Creek, and then demonstrate how we're actually going to monitor and quantify success of this restoration project. And kind of throughout the talk, I'm going to be talking in different parts about how we're really looking to take what is currently more of a single-threaded meandering channel and kind of produce a more anti-branching dynamic network of braided channels throughout the preserve. And just as a general outline, I guess I'll start talking about stream restoration at Swaner and kind of continuing on with the legacy of that, give a brief history of beaver in northern Utah, and then we'll get into the real details, why we want to use BDAs, how we're going to actually implement this project, and what our goals and monitoring schemes will be. So with that, let's just talk really quickly about some challenges on East Canyon Creek. As some of you might know, in 2000 and then again in 2010, the state of Utah listed East Canyon Creek as an impaired watershed. And through that process, they issued what's called a total maximum daily load plan, which essentially implements problems and then identifies potential solutions to those problems for the entire watershed above East Canyon Creek Dam. And kind of high on that list was actually high nutrient loadings within East Canyon Creek, particularly nitrogen. And factoring into that was also there's a lack of riparian shading. And those two factors together actually work to increase primary productivity within the waters of the stream, which in and of itself sounds like a positive thing, but what that then does is causes a lack of dissolved oxygen at night, because all of those plants and algae that are living within the stream actually start respiring along with all the other animals that are in the stream. And so dissolved oxygen levels decrease, which is not good for fish species, particularly our native bonny-billed cutthroat trout and suckers, who are not as able to adapt to the low dissolved oxygen levels. Kind of factoring in with that was a simplified stream habitat, so there's not enough places for these fish to go and find optimal living conditions because of the single stream network where there's just kind of a meandering channel, as you can see here. There's not a lot of habitat dynamics. There are a lot of places where they can actually go hang out. And kind of all of this is driven by a lack of floodplain connectivity. So if you're not connected to the floodplain, you can't grow new riparian vegetation because you're not introducing new channel dynamics, and you are not able to actually store these nutrients in ways that can be used on the floodplain, such as by grasses and trees. So they get stuck in the channel, and then that creates this feedback loop of low dissolved oxygen. But the good news is that Swaner has kind of a long legacy of actually implementing stream restoration practices within the Schneiderville Basin, and we're trying to kind of work on that and implement a beaver-centric ecological restoration plan, if you will. Back 25 years ago, when Swaner started the Natural Resource Conservation Society, I actually started off that restoration, kicked it off by filling in drainage ditches and kind of rerouting and naturalizing the hydrology of the area. And Ducks Unlimited built some ponds, and then right after that, for the first time in anyone's memory, we got a bunch of sandhill cranes on the preserve, and that was like a really cool, really big, immediate result. Trout Unlimited and Vail Resorts and others have since kind of followed up on that and done some really cool projects, planting a bunch of willows and trying to stabilize banks to prevent erosion and increase the trout habitat of the stream. And so we're really looking to just build onto all those projects and continue that legacy of restoration with this Beaver Dam Analog project. So why beaver anyway, you might ask? Why don't we use some other restoration technique, which there's many of them out there for streams? But the reasoning for using beaver is actually they're one of the best examples out there of ecosystem engineers who change the environment to better suit themselves. The cool thing about beaver is while they're not necessarily altruistic in doing that, is that literally hundreds of other animals have adapted to that process over millennia. And so when they change the ecosystem, it's actually very beneficial for ecosystem services such as water filtration or primary productivity or the provisioning of riparian trees, but also like the breeding biology of hundreds of animals, from waterfowl to otters and obvious things like turtles and amphibians, all the way to not so obvious things like flying squirrels and bats, because, for example, bats, they need a really long runway, right, to pick up water because they can only pick up water in flight, and beaver ponds actually offer the perfect opportunity for that because they chop down trees and kind of open up the canopy so bats can actually swoop in and grab water. So yeah, really when we think about using beaver, we're thinking about doing like a whole ecosystem restoration and not just focusing on like a single part of the ecosystem or a single process, but we're really trying to restore this entire stream riparian area. And then most importantly, like I was talking before, there's a lack of complexity within East Canyon Creek. These beaver are really, really good at adding complexity back to a stream, and they do it essentially for free. Like you have to treat it once and get the beaver there, but then as long as the habitat is maintained at a high level, beaver will continue building dams and continue changing the way the channel networks are formed. And eventually you'll go from a single threaded, slightly incised channel, and you'll work your way through time, and then boom, you'll be in this kind of beautiful chaos of where's the main channel, why are there so many beaver here, how do I walk through this? And it will be great for a bunch of other animals, and you'll see drastic increases in riparian vegetation and the like. So with that, I guess I'm just going to move on to a quick background on beaver in northern Utah and kind of explain why they're so important and why we are trying to get them back to this area in particular. So as you may know, beaver are actually super important to the development of the United States. Actually, some of the first goods that were shipped from North America back to Europe were beaver pelts. And the reason being these fur hats that were so, actually wool hats, I guess, that were so, classic to that era. Everyone from the, colonial army hat to the Abe Lincoln top hat were actually mostly made of beaver wool made from beaver pelts. And so the settlement history of the United States actually directly tracks this this resource, if you will, where the French first, went up the Mississippi River and founded St. Louis up here in search of beaver, and they also came down the St. Lawrence Seaway up in the north. And as we slowly moved across the Appalachian Mountains, we were just always searching for more beaver to sell. In fact, by the time we made it to the Intermountain West and really started like the era of the mountain men, as people say, in the early 1800s, 1820s, into the 1830s, a single beaver pelt was worth about $2 in 1830s money, which equates to about $50 in today's money, and that was the money that the trapper was getting paid. So once the trapper had sold it to a wholesaler, and they were actually selling those pelts, say in New York or London and Seattle, they would go for as much as about $7.50 a pelt in 1830s money, which translates to over $175 in today's money. So really, beaver were almost as good as gold because you couldn't really mine them out. I mean, we tried, but they're still here, so we didn't fully mine them out. So really, at the time of beaver's zenith, at the time of the highest trapping of beaver in northern Utah, there's really three big companies or organizations that were doing it. There's the Hudson Bay Fur Company, which is the local kind of head man was Peter Singay Ogden, which is what the town of Ogden is named for. There was the American Fur Company, which was run by a guy named John Jacob Astor, who's actually America's first multimillionaire. He was the first American to do trade with China when he sent beaver pelts from his port city of Astoria in Oregon over to a port city in China. And then there was kind of the famous Rocky Mountain Fur Company. These are the mountain men of the era that everyone's so familiar with. It was founded by William Henry Ashley, but illustrious names: Jim Bridger, Jedediah Smith, Hugh Glass, Jim Beckworth. At the time, they were known as Ashley's 100, and that kind of represented they were more of a co-op than a company. They were kind of like a group who incorporated together, and then they agreed to all sell their pelts as a singularity, and they actually redefined the trapping industry. Prior to their involvement in the fur industry in North America, most of the trapping was actually done by Native Americans, and we would trade with Native Americans for beaver pelts or otter pelts or the like. However, these folks kind of pioneered what was called the Rendezvous System, where the mountain men would go out and trap, and they'd bring all their pelts to a central location somewhere in the Intermountain West, and they'd all sell them, and they'd have a big party, and they'd buy all their supplies for the rest of the year at this rendezvous, and they'd go on and explore some more and find new beaver pelts somewhere else and do the same thing in that shit. So what was really cool is actually of those rendezvous, the first four were actually held right here in Utah. The very first one was Burnt Fork on the north slope of the Uintas. It's a Burnt Fork of the Green River, and it actually flows like straight out of Utah into Wyoming. The next one was held in Cove, just north of Logan in Cache Valley. And then the two after that were in what's labeled as Sweet Lake, but it's actually Bear Lake in our modern nomenclature. And so what that really illustrates is this area of northern Utah, the Upper Weaver, the Upper Bear, and to a certain extent the Upper Provo rivers were all like hotbeds of trapping activity in that era because they were so close to these rendezvous. There was probably tens of trappers out in this area actually collecting beaver pelts and trying to find new hotbeds for them to make their year's pay. There's actually fairly good evidence of that from William Henry Ashley and Jedediah Smith. We have their journals that kept really good records. And we can see that they actually both entered the Upper Weaver drainage right over here in the 1825, 1826 era. There's not really good records for East Canyon Creek, or no one really mentions it itself, so we can't actually say for sure if anyone trapped here, but the likelihood that someone didn't trap here is pretty low. So really what that illustrates to me is that by the time the original pioneers were coming in the late 1840s, and definitely by the time that the stagecoach stop was built at Kimball Junction in the 1860s, there was probably very few beaver
where the influence of beaver was significantly decreased, at least in the upper East Canyon Creek, because of that legacy of trapping. And there's some proof of that. I actually found this 1869 General Land Survey map. And just for a little, I guess, orientation, we're sitting right about here. This is the original toll road that went from Salt Lake to Colville and the rest of the Upper Beaver, so I labeled it as I-80. And you can actually see on this map there's a really big side channel. Like, there's no islands on this map, it's not that scaled. But this side channel went for a mile or two. So there was significant complexity within the stream itself that doesn't exist today. So we know that within the historical records, East Canyon Creek and Kimball Creek were much more complex than they are right now. Further, if we look just one drainage over to the sister drainage, essentially, of East Canyon, you can see on Silver Creek there's some serious chaos going on right in here. If you actually go and look at that site today, the floodplain is super wide. It's like irregularly wide, but the channel is a straight shot. It's been completely straightened, and they've eliminated all of that complexity. It's kind of a very common thing that's happened. And to illustrate that a little bit on the preserve, I'll orient us. We're sitting right here, and this is the northwest side of the preserve right there, right near I-80. This is what that looked like in 1952. You can see that there's all these little gray dots for willows and cottonwood groves throughout that. You can see that there's a decent amount of complexity, and that there's really willows spread throughout the floodplain area. It's not just next to the channel, but it's really pretty heterogeneous throughout that. And if we flip forward 10 years, 1962, there's a pretty similar amount. There's not that much change that's happened. The interstate still hasn't been built yet. And if we flip through about 30 years, you can see a significant change with serious straightening, loss of a good deal of floodplain right here. And then throughout, there's really a loss of those willow groves, those cottonwood groves. They're really only occurring right here and a little bit right there. So we'll just compare those two again. If we fast forward one more time step, about another 25, 30 years, we can see that that's continued. There's a little more willow regrowth along this section, but there's a general straightening trend that's continued. And this is the kind of thing where we're trying to take this channel, right, and reconnect it to its floodplains on either side so that it can meander and then eventually split and create islands and increase that complexity. So now that we've talked a little bit about the history, I'll just dive into why we want to use BDAs in Swaner in general. So, taking it back a second to East Canyon Creek's impairments, essentially what we established earlier based on the TMDLs, the total maximum daily load recommendations established by the state of Utah, is that there's a lack of complexity and riparian shading, and there's not a lot of floodplain connectivity within the creek itself, which, combined with high nutrient loads, leads to a lot of macrophytic growth, reducing the amount of dissolved oxygen, and then increasing the amount of non-native species like brown trout relative to native species, because brown trout are used to really big, really productive rivers where they typically went through oxygen limitations, whereas cutthroat trout and other native species are not as adaptable. And so that's a suboptimal condition, right? So luckily we have essentially a framework to work under to think about, so if we have these negative conditions, how can we give the ecosystem a boost using restoration techniques to push ourselves out of an impaired condition and maybe into a better, more naturalized, more functioning state. And that's called process-based restoration. It was kind of laid out in a foundational theoretical paper by Beachy in 2010. And we've already established some of this in this talk, right? We know what the symptoms are, which are lack of dissolved oxygen, increasing amounts of non-native species, non-functioning nutrient cycles. And we know the process has something to do with river complexity. And so I want to explore that a little bit more here. If we look at river complexity, the controlling process really for that is channel evolution, or what some people may refer to generally as geomorphology. And so this is just kind of a general diagram that illustrates, as you go through time, how you can have changes within your channel, and how it's not just like a linear process. It's not a successional process, but it's a dynamic process where you can go from a single-threaded channel and then downcut and be fully channelized, and then you can go to having inset floodplains, and then you can go back, and then you could
start at what's called a stage 0, where you're all braided, and you can go all the way around and get back there. So right now, I would make the argument that East Canyon Creek is somewhere in a 1.5, somewhere between the sinuous single thread and the channelized. It's not, in most areas, it's not that down cut that it's that difficult to get to the floodplain. So what we really want to do here at Swaner is we want to take ourselves from that 1, and we just want to go backwards 1 step and make it into a anti-branching braided channel, because those channels naturally have greater deliveries of ecosystem services because they're more dynamic, and when you have more dynamic habitat, there's more processes that can occur. In addition to more processes being able to occur, they can provide habitat for a greater number of species because there is that segmentation. There's different niche spaces. So the good thing is we know that beaver, we've already established that beaver are very influential in that dynamic, and we know that, say, if we have ourselves in something like this, we can add more beaver or add more beaver-like structures and work our way backwards by trying to degrade the channel, by trying to do essentially the opposite of erosion, right? By trying to allow sediment to build up and slowly get ourselves back to that same floodplain surface where we then can have connectivity and allow for those natural vegetative and fluvial processes to carve new channels and establish better vegetation and better habitat for a multitude of species. So that's essentially exactly what we want to do with the BDAs. And so now we've kind of reached a full definition of our restoration process under this process-based approach. So we'll use beaver or beaver-like structures to restore all local sites, and then we're going to define our measures of success underneath what's called an adaptive management framework, which is just saying we're going to monitor what happens, and then if what we want to happen isn't happening, we're going to make changes to what we're doing to reach our goal. So how are we going to do that? We decided that instead of just trapping a bunch of nuisance beaver and throwing them out into the preserve, which was unlikely to have the desired effects at the location that we wanted it to, that we would actually kind of start everything off by building our own beaver dams, start immediately reaping some of those benefits in terms of habitat and ecosystem services, and then allow the beaver themselves to just come back in and hopefully take things over and keep this restoration project going ad infinitum. And so this is kind of just what some of these structures look like as they're being built. This is us weeding some willows. This is a sweet close-up of what the actual dam looks like once we have it constructed. And this is Kimball Creek right here with, you can see a couple BDAs and some nice river flow. So why did we decide that? Essentially, we knew that we already had some beaver on Spring Creek on the preserve. This is actually their main dam right here, right near the mouth of East Canyon Creek. And you can see they have a small little secondary dam up there. But we knew that we had beaver not only on the preserve, but also upstream near Park City and downstream within East Canyon Creek Canyon itself. So we didn't feel like beaver were the limiting factor. We felt like beaver habitat was the limiting factor. So we kind of took the build it and they will come approach. Essentially, we chose 2 areas that we thought had close to suitable beaver habitat that were fairly close and had evidence of recent beaver use, recent beaver chews, recent beaver activity within the willows, but no damming evidence. So we chose both of those 2 locations to be our main restoration sites. And this is just a sweet photo of a honking beaver just to prove that they really are there and actually just spontaneously build a dam. So how do we actually build these Beaver Dam Analogs? Essentially what we do is we take some real nice, really big fence posts and we...
Do you want me to play it?
Yeah.
Okay.
We take some real nice, really big fence posts and we pound them into the stream in rows across about a foot each, about a foot apart. We usually do 2 rows if we're trying to build a really big primary dam, or maybe only 1 row if we're trying to build a quicker structure. And then we take a bunch of rocks and cobble and line the base to really strengthen that base and prevent underscouring. At that point, we take a ton of willows that we harvest from the local site, and that's what we're doing here. We weave them back and forth, both perpendicular to the flow and then parallel with the flow. And what that does is it diversifies the flow pattern and is essentially better at slowing down the water than if you only build in one direction you create chutes that just the water is much more powerful. It shoots right through. So after we've done that, the final step is then we take a bunch of fine sediment, sands, silt, and even like root wads of grasses and such, and we throw it on top of the dam structure itself to really seal everything in and provide that nice water retention capacity. What that does is it then forces the water to flow around the dam or over it, and the around the dam part and onto the floodplain is then what allows us to store more water within the floodplain itself. And this is just kind of to show that this is a really useful stream restoration process because it only requires really one power tool and it has very limited impacts to the floodplain surface itself and very large restoration potential. So essentially what you get for what you damage is really high, which is really good from a restoration perspective because we don't want to have to destroy a bunch of things and then reseed it in order to just restore a hydrologic regime that we really want. So yeah, this is the hydraulic post pounder here on the left. That's the most expensive part, but luckily East Canyon Creek's Watershed Council has their own that they lend to people at will, and we had it practically for all summer, so that was great. And then from there, we just used classic kind of garden lockers to harvest willow, buckets and shovels to harvest sediment to seal it in. And kind of an important thing to think about that we wanted to think about, right, is one of our main goals here was to prolong this, to establish beaver colonies, right? So we wanted to choose restoration sites to build these complexes of beaver dam analogs that had high intrinsic potential for beaver habitation. So things that we were really looking for, and this is an example of our restoration site down here, is willow cover. And while this might not look like abundant willow cover, it's not quite abundant willow cover, you kind of have to work with what you're given. And so we chose to establish this as one of our sites because there's a ton of willow cover. And then there's also some relic side channels, which is really important for beaver. That's actually where they like to build the majority of their lodges on larger stream systems. The reasoning for that is when there's really high flows, that is where the water's the slowest. So that's where they're the happiest and they're the least likely to have their house destroyed. So you can see actually one of these historical meander bends right here. And we built enough structures actually across the stream reach right here that this entire thing is now underwater, which is pretty cool. And another kind of factor is we wanted to establish this floodplain connectivity essentially immediately. And so we were looking for areas that had smaller levels of incision. This is just kind of a schematic for this area that's showing it's about a meter between the actual base of the stream, between the stream bed and the floodplain. And so with a single Beaver Dam analog, we can actually divert water onto the floodplain at base flows. And then at bank flow flows, I mean, we're going to have a ton of water on the floodplain, assuming they survive, which will be amazing. And then actually, once we've picked a site, we then walked through and picked locations for these Beaver Dam analogs based on what we were trying to do at that site. So on this example here at the left, you can see two dams, right? You see one here and one right there. You might be wondering, well, why would you build them so close to each other? That seems dumb. Well, the idea here is we would build a primary dam, right? That's going to stop a lot of water, divert it off onto the floodplain, soak it up within the soil, and really provide some really good habitat both for beaver and for the growth of riparian woody vegetation. And then right underneath it, we'll build a secondary dam, which is essentially reinforcing that primary dam, right? What it's doing is it's backing up water to the primary dam and preventing that, essentially the force of the water that's falling over that primary dam from scouring back underneath itself and causing a structural failure. So really it's kind of like an insurance policy, and that's how we build all of these complexes. And so you can see on this complex, you know, we have one dam here, we have another dam here, we have a primary dam here, a primary dam there, and the final constriction dam right there. And the reasoning for that is we want to just iteratively slow down that water so that there's a strength in numbers, if you will, of like reducing the velocity within the stream altogether and then spreading that water as far as possible. And so what we did to check on the spread of that water is we installed well points at various locations up to 100 meters away from the stream channel. And actually right now, I just walked this site today, there's water that is flowing from this dam all the way down here and is re-entering the stream way the heck down here. It's like completely wetted this whole side. which is pretty incredible. It actually goes beyond our well field. Shocker. We couldn't predict. Okay, and so finally, I really just want to talk to you about what our specific goals are, and then specifically how we're going to monitor to determine if we've achieved those goals, and kind of walk you all through exactly what we did in this project. So really, as I've been talking about throughout this, none of these should come as a surprise, but we want to diversify the stream habitats, we want to diversify like the pool depths, the runs, the riffles, we want to create some plunge pools, we want to create really expansive wetlands, we want to create things that aren't currently on the landscape within the stream. We want to enhance habitat for native species. Really here I'm talking about cutthroat trout, Bonnyville cutthroat trout, and potentially there's some chubs, leather-sided chub that might be in this drainage that we haven't been able to verify yet. And there's also the potential to restore an endangered sucker, bluehead sucker, which is native to the Beaver River and is found actually in Silver Creek, but is not found in Kimball Creek that we know of, Kimball or East Canyon that we know of. So in order to do that, what's really important for those species is establishing late season stream flow. And so that's kind of the water, pushing water out that I've been talking about. We want to increase the temperature variance so that different life histories of different species and different life stages can kind of maximize their growth. So some species like to be really hot when they're young and some like to be really cold. And you need to have that variance in order to have them all within your system at once. And then really importantly, I think this is kind of a highlight of what we're trying to do, is to increase nighttime dissolved oxygen. And our thought process here is that beaver ponds are actually, because they're so deep, it's more difficult for macrophytes to grow in them because they don't get as much light down there. And then they have these plunge pools, right? So the plunge pool is actually dropping, through the air. The water dropping through the air is oxygenating the water right at the base of each of these dams. So essentially, we're building like miniature waterfalls that are like oxygenating the water slowly. And if we could enhance that by a magnitude of 10, then we would not really have a dissolved oxygen problem in the upper East Canyon Creek anymore, and we would be better able to support some of those native species. And on that same line, we want to reduce the amount of plant available nitrogen that's actually within the stream. So we want to force some of those sediments that have plant available nitrogen to be deposited within the floodplain, and also to be stored within these backwaters behind beaver dams, and prevent them from being integrated into macrophytes and algae within the actual stream system itself, downstream from our complexes. Finally, importantly, we want to enhance the woody riparian vegetation and encourage beaver colonization. So, how are we going to do that? Essentially, we already had some pretty cool BDA sites that were built in 2015 and 2017, I want to say. They were kind of in a state of disrepair because they weren't taken over by beaver. So we were like, okay, we'll take these original spots and let's just add some more complexity to them. Let's keep them going. Let's give them some more food. So essentially, we either built new or repaired 3 structures at each of those complexes. And this is just kind of an example. This was the original BDA here. And it caused a big piece of erosion here, which you might see as a negative. But what it also did is it created this island, which doesn't look like an island yet because it's at high flows, but it definitely turned into an island this year. And then it established all this new floodplain right along here, which will be great opportunities for willows and cottonwoods to establish along the stream reach. So what we decided to do is to prevent more erosion from happening here, and on this riprap along here, we built one just below it, so that hopefully, if this one blows out too, it will form a sinuous S-bend and keep a grading stream. Aside from that, we wanted to essentially start from scratch in order to have a really good research project. We wanted to start from scratch and build 2 new heavily monitored complexes. And for each of those complexes, one on Kimball Creek over here, and one on East Canyon Creek over here. We built 5 to 6 structures, and then we installed a bunch of groundwater monitoring wells. We did extensive fish surveys. We did some really accurate GPS surveys to really build what's called digital elevation models, but they're just topography, like topographic maps, but at like the centimeter scale for each of these niches. And then finally, we just wanted to, And this is a great shot of what this Kimball Creek site looks like right now. You can see all that water I was talking to you about is stagnated right here, and it's actually flowing all the way up that way. It's actually two-water the stream pretty considerably, which is interesting, but it's all coming back. And then finally, we wanted to essentially compare these restoration sites to natural beaver dams that are within our system, and to control reaches that we didn't impact with our restoration, to make sure that we're actually getting the benefits that we're hoping to get, or that we think we're getting. So in order to do that, each of these restoration sites had an upstream control reach that was over 200 meters upstream and not impacted by any of our structures. And we also identified this really nice beaver complex right on SR 224 as you're going towards Park City. And so we're able to do a comparison of sort of controls and positive controls to assess how these restoration projects are actually going to play out. And this is a photo of that natural beaver dam. You can see it actually, beaver dam complex, actually goes underneath the highway. There's a culvert right here. And there's if you go down and look at it, there's an old beaver deceiver, they call it, a pond leveler, some people might know it as, that they built right here because there was a beaver dam right there. And if you walk this trail, you can go see it, but there's essentially a big cage and a piece of tubing that went through the beaver dam so that they could control the level of the pond and so that the beaver didn't build it too high and flood out the highway or cause structural damage to the highway itself. Oh yeah.
Oh yeah.
So this is actually just a video of our Kimball Creek site. It's going to show you a little bit about how things changed over time. This was before we built anything in June. And you can see as I'm zooming back here, you can see some of these kind of paleo channels or these old channels, both on the bottom and up here on the top. This was right after we built everything. And if you notice, the water levels are almost identical to that June flow. So even though we were comparing kind of peak flow to base flow, these BDAs have really made it so that they're actually at about the same level, which is just about to be in full stage, not quite. But. And this is the most recent shot from just about a month ago. And you can see already over here there's significantly more water within the soil, and it's actually completely overflowing from the banks. So much so that it doesn't look like there's that much water being stored behind these dams. But that's good. We actually want water stored in soil because water stored in soil has less temperature variance than water stored in an open channel. So it's less likely for the stream to freeze solid, and it's more likely for the stream to be cooler in the summer based on having more soil water versus stream water. And then this is the final one that the Swaner staff all built together. That one looks really good. I'll give a cool close up. Cool, so how are we going to understand if we meet our goals? Essentially the way I structured this section is I kind of gave each of the goals that I described earlier a little icon. So for stream diversity, I have a little anabranch. For native species, I threw in a bottom of the cup. And then vegetation in the riparian zone, and my favorite little beaver cartoon for everything. So in order to understand how we're changing the actual stream habitat, we did some, it's called real-time kinetic GPS surveys, which I mentioned briefly before, but I'll describe, I guess, more thoroughly now. They are super accurate. It's like survey-grade GPS equipment. So you can get usually 5 to 7 centimeter accuracy, not only in the X and the Y direction, but also in the Z direction, which is like height. So you can actually create a digital elevation model of the stream that is like, these delineations here are in centimeters actually. So what that allows us to do then is to do repeat surveys and actually see how the stream channel is changing. And not only can we see how the stream channel is changing, but we can do essentially math with these, and we can subtract, the original from the current, and actually see where is erosion and where is deposition happening, and get an idea of the sediment budget for a given reach. So if we're actually grading the stream reach like we want to, or if we're not, it allows us to have a check on that. Additionally, because we know exactly because we know the exact, essentially, topology of the stream now, we can create a flow model, and at a given flow, what sort of stream units will we have? Will we have riffles? Will we have pools? How deep will they be? Because we know the water elevation at a given flow, that will allow us to essentially see how complex the actual stream habitat is and quantify that. Additionally, it will be really easy to see side channels and integration and island formations, so we'll be able to quantify how many channels there are within the stream reaches before and after. So enhancing habitat for a native species is a little more complicated. It's kind of hard to see in this graphic, so I guess I'll just walk you through it orderly. But essentially what we want to do is we want to install Beaver Dam Analogs, which will slow down water and provide better habitat for beaver. And we want beaver to build more dams, which will thereby essentially create differential flow velocities. So we'll have erosion in some places and deposition in other places, which will build up the floodplain, connect the river to the floodplain, enhance the pool habitat for the species. Because cutthroat trout are kind of lazy; they just like to hang out in pools. Really, optimally, they like to hang out in pools and get essentially insects just fed right to them within the drip. So they'll do really well, hopefully, and then they'll reproduce, and there'll be a bunch more of them. But the beaver will then have more riparian habitat, and there'll be more beaver, and it'll just kind of be an endless feedback loop where they start doing the restoration for us. And how we're going to quantify that is we did a bunch of fish surveys this summer using a process called electrofishing, where you just run a mild current of electricity through the water, and that stuns the fish because they have an organ that actually senses electromagnetic current, and you can pick them up really easy. We then tag the fish with a hit tag, which is essentially exactly what you use for your pets. It's like a passive integrated transponder. So you just give it a little zap and it sends you back a unique code, and you say, oh, this fish's name is Jim and I caught him before. And so with that, we have the length and the weight of the fish at the time of their first capture, and we can compare that to the length and weight at the time of their subsequent captures. And by doing that for both the control, the natural beaver dam, and the restoration reaches, we can get an idea of how quickly fish are putting on biomass within different habitats. Additionally, we have a bunch of, actually I just finished keeping up the temperature loggers today. We have a bunch of temperature loggers and dissolved oxygen loggers. They're in the water that are telling us what the temperature and dissolved oxygen content is for these specific locations within the restoration reaches. And then we installed a ton of groundwater monitoring wells. We have about 6 to 7 at each of the restoration sites, which will give us an idea of how much water is actually being stored in the soil compared to how much water is flowing through the system. And then also I've been collecting a bunch of water samples, both above, below, and within all of the restoration complexes, as well as natural beaver dams, the upstream one I showed you, and also down in East Canyon Creek Canyon near Mormon Flat. So we'll be able to tell, are these BDAs actually filtering water to the same extent as natural beaver dams? And is that creating a substantial response that will then help our dissolved oxygen problems? Further, we really want to enhance the amount of weed riparian vegetation. So I have a drone actually that we flew over each of these sites, and because I can control the elevation of the drone, we can get really close and get actually we can get pixels, individual pixels on this imagery that are about 2 centimeters. So we can get really accurate imagery that will capture what vegetation is there, and then we can run those pixels, essentially the spectral responses of those pixels, through an algorithm that will help us classify them based on both their color and their structure into different vegetation types. So we can tell the difference between, say, willows and cottonwoods versus bare ground versus sedges versus cattails. So that will allow us to create classification maps like the ones over here, where we can say, say this one's 2019, this is what it looked like, and after a restoration procedure, in 2021, that's what it's going to look like. It will allow us to compare across time the responses of weed riparian restorations. Also, because we know where willows were planted before, we can actually give a comparison and give an indication of how willow growth is related to plantings of willow from those previous restoration works that I was talking about versus natural reproduction of willow in our sites. And then finally, we really want to encourage beaver to actually come build dams to live on the preserve in areas other than Spring Creek. So in order to do that, really the best way to do it is what's called cache surveys. So in really cold climates like in Utah, beaver build ponds, right? And their ponds freeze solid at the top. Actually, I was just up at Fish Lake National Forest last week and I walked across the Beaver Dam. It was kind of scary. But they freeze solid, and what that means is they can't eat for sometimes months at a time. So what they do to adapt to that is they build what's called a cache. So that's what it looks like above water before it freezes. And what they do is they stab tasty vegetation into the bottom of the pond. And when the pond is frozen over, they actually can just swim out of their little tunnels, either if they're bank lodged or island lodged. They can swim out, grab a nice stick, bring it back into their house, and then share it with the whole family. It's pretty cool that they actually adapted to live in climates by figuring out how they can store food for themselves in their own homemade refrigerator. So far we haven't seen any of this happening yet. I have seen some beaver activity, particularly on the East Canyon Creek site north of I-80. There's been a lot of actually beaver chew activity in that area, but I haven't seen any evidence of lodging or cache building as of yet. Dispersal usually occurs in spring for subadult beavers, so usually when they're 1.5 to 2 years old, they'll actually disperse and go find their own territory. There's been a lot of work actually looking to see where do they go, what's their natural enclave. And they will go actually upstream or downstream. It's kind of random. They just like go off on a hunt to find new things. Males tend to go a little bit farther than females, but we'll see what happens in the spring. And then, as I was talking about before, we want to have all this in an adaptive management capacity, right? We want to understand what we're doing, and we want to understand how we can continue to work towards our goals, even if our first go at it doesn't fully meet our expectations. So essentially, for this project, what that means is we have a planning stage where we're going to pick, where we want to restore. So we've done that, and then we do some pre-monitoring. We build the BDAs, and we come back and monitor again next year to see, okay, so what have we changed? And then we decide, so are we achieving those goals? All of them, some of them, none of them. Then we have specific adjustments already set up in place that's saying, okay, say we've achieved all our goals, but we haven't gotten beaver back. Maybe now it's time to transplant beaver onto one of these sites, or something like that, where we have a 4-year window. If we don't have beaver back within 4 years, but we've achieved all our other goals. So all of that will be summed up in an exciting forthcoming document, the Swaner Preserve Restoration Design Report. It will be out sometime this winter once I have a chance to finish it and actually get some of the initial data analysis done. So with that, I just want to give a special shout out to a bunch of people who helped me out in the field this summer. We couldn't have done it without them. It was literally thousands of man hours, both building, sawing, cutting, etc. Nell, Drew, Janice from Wild Utah, Rhea, Margo, Danny, Rachel, and then a couple of my friends who came out and worked for free for a couple weeks. They were all awesome. Thanks again to the funders, particularly to Swaner, but also to the people who supported me and at Utah State and the Department of Environmental Quality of Utah. They've been really kind of at the forefront of some of this research and are really excited about some of its potential. So it's pretty cool to have state agencies buying into all that. And with that, I'll give a cheers. Thanks for coming. There is a good beaver brewery out there if you are a true beaver believer. Take any questions. You guys are good.
Yeah, so fascinating presentation. I've been back to Swaner for the last 22 years and covered anything that was on here, and again, just after the presentation. On the BDAs, if beavers come along, will they build near BDAs or next to, or what are you expecting as they come upon the BDAs?
Yeah, so they do both, is the short answer. Sometimes you'll see them just completely take over BDAs, and they'll just essentially, like, eventually you won't even be able to tell there's a BDA there, because they'll just literally pile stuff on top of the post, and the post will be completely gone. You'll also see where they come in and they're like, yeah, it's a cool BDA, but I hate it, and then they'll just build right underneath it and flood the BDA out. So it's like, it kind of depends. There's a really cool project actually just north of the state line in Idaho at a place called Birch Creek, where they built a bunch of BDAs and transplanted some beaver, and they saw both of those things happening there. They took over some BDAs and they also just completely flooded some BDAs.
Interesting.
Yes.
This will be the beaver border around the Jewish temple, 224.
Yeah. That was the photo that I showed. That was the Jewish temple. Yeah, that's a really cool complex.
Basically ankle deep.
Yeah.
Ankle deep, that's all it was, back and forth.
And now you can practically drown in
Yeah, right.
it, or at least get stuck in the mud.
Thank you.
Yeah.
So the BDAs you put in north of 80, there's houses along that creek. You're not worried about water infiltrating
Yeah.
the houses?
The houses are they're high, and we chose our spot strategically there because there was a pretty stark vertical separation. If we had built closer down, for example, near where the Spring Creek Trailhead is, there's a lot shallower of a divide there where there's more of a problem area. So we kind of intentionally chose that spot because we felt like there was a much less likelihood of us causing problem damage. Yeah, and also the farther up the hill you are, the less likely the beaver are actually like going to come up there and go grab your trees and cut down your apple tree or cut down your aspen and such. So we felt like there was a good separation. Yeah, it's always kind of a balance, and that's within the adaptive management planning isn't just like how do we encourage our projects, but it's also like, oh crap, like we clogged a culvert, what do we do? Or like, beaver now like chewing down every aspen in the Spring Creek neighborhood. What do we do? So there's got to be some attention, I guess, to property damage, and that's kind of what we get those spots.
What kind of impact do you expect for the BDAs that you've built right out here? We obviously get some pretty heavy flooding in the spring.
Yeah,
How
totally.
will that impact that area? The flooding doesn't seem to be as drastic, and I'm guessing that's why you picked this area.
Yeah. So the hope is that they'll survive several years, right? And then they'll continue to build up sediment behind them and increase the floodplain. What might actually happen is we might see some get blown up, which isn't the end of the world, because when you blow out a beaver dam, you create some of those hydraulic differences that I was talking about, which is going to inherently improve habitat and then also work to cut new channels. And what a lot of the woody vegetation needs, the native woody vegetation, for example, willows and cottonwoods, they won't germinate on an upper floodplain surface. What they need is freshly deposited like silt for them to have their seeds land on, and then they'll germinate and grow super quick and get up to like a meter high in their first year. So while a blowout might seem like a failure for some aspects, it might be a success for other aspects, and it's a chance for us to then go back and readdress that reach. And eventually, the idea is if we have multiple channels, then there's less force in each channel, right? And so that's kind of what beaver work to create, is they actually slow down floods, and they prolong the period of flooding, but they make that like peak discharge, or that like maximum force of the flood, less. And they do that by dispersing the water and by having it infiltrate into the soil and not just like caravanning downstream at maximum velocity.
And I heard you mention seedlings. Is there ever a thought, or is it a common practice to ever kind of just transplant native and plant?
Yeah, totally. And Swaner has done that extensively in the past. And if we could get the money to do it, it would be awesome to like just bring these beaver ponds and just knock in a bunch of willows. Yeah, that would be phenomenal. And I think we'd see like immediate takeoff. It would be really cool.
So what would be a cost of funding BDAs?
The cost of funding the BDAs?
Funding
The transplants? Oh, I have no idea. Anyone have any ideas back here?
Are we using bare root? Are we using container plant root?
I think it's pretty cheap if you're just making cuttings, right? Because you can cut a willow and essentially pound it into the ground, and then it will just grow roots off of its own branch. So that's really cheap. Where it gets more expensive is if you want to really do some targeted species. So if you want to like get a big cottonwood back in there, then you're gonna have to plant a larger one. You're gonna have to cage it, because if there is a beaver there, he's gonna cut that down right away. And you're gonna have to like be more watchful. So it's gonna be, you know, a higher initial investment and a larger long-term investment. So that's kind of why we want the native kind of natural germination around it. Yeah.
Do you have a population goal for the beaver?
No, we don't have a specific population goal. I mean, so each of these restoration complexes that we've done right now are probably what would be like a single colony in the wild, right? So if we got 4 colonies back, that would be like full success, right? Anything on top of that would be them like naturally expanding in areas that we didn't actually build for them. Yeah, I mean, getting the 2 that we built super heavily would be awesome. I would consider that a pretty big success.
Yeah, first of all, I'd like to thank you and Swaners and everybody else who supports you for trying to do whatever you can to help East Canyon Creek. Will be honest, I'm on the other side of that. The beaver thing, I've been seeing a lot of studies. Most of the studies say beaver are good for streams. There are studies now coming out that saying that in certain areas there are not. There have been streams that have been rehabilitated and they've installed beavers to help. They're now blowing those dams out and moving the beavers away. There was a very good article that I hope that you may have seen that was in Trout Unlimited, the Trout magazine, in October, I think, of last year, that kind of mentioned the contradiction of are beavers good or not.
Mm-hmm.
And it made a kind of a conclusion saying it says it depends on the stream.
For sure.
But the only thing they could find was that beavers are very good and very helpful, and they do all the things that you say they do on high gradient streams. And on low gradient streams, they sometimes aren't an advantage. And I just, I know that you're going to look at it, and that's when you're going to prove you right or wrong.
Yeah.
That's great. Again, I applaud you for trying, but I just want to make you aware of those other studies that are being done by everybody. Wisconsin's moving all their, well, not all, but a lot of their streams are taking the beaver away again.
Yeah.
But this is a very low gradient stream from the barn all the way to Jeremy Ranch. You don't get very much draw.
For sure. And I mean, what you're saying is completely correct. There's areas where beaver can be much more beneficial than other areas. And there's also been contrasting studies. Like, for example, there's been some studies in the eastern United States that show that beaver ponds actually can warm streams versus there's studies in the western United States that say the opposite. So they're as with any question within ecology, there's a lot of kind of intangibles that are like site-based and you can't control for. I would say the redeeming feature for me in looking at beaver and Swaner is, to me, Swaner, when you just look at the landscape, and you look at the topography of it, it has the appearance of like a classic beaver meadow to me. It looks a lot like these high outline depositional beaver meadows that you see throughout the Intermountain West that just literally have millennia of beaver habitation that has just been slowly building them up. And when you core these areas, when you core at Swaner, you actually see these very strange substrates that you can't explain very easily without like some sort of massive flash flood event or beaver. And so I think, at least from my perspective, I think it's worth a go. And yeah, I mean, if things end up terribly, you can always take them out. But if you don't give it a go, you never know what you can achieve.
Yes, and I agree. I appreciate that you're trying.
Yeah.
One more question. What species is that sucker that's, you said you don't have the protected bluehead?
The bluehead sucker.
What species is in that stream that is very predominant, especially right behind Pheasant Bay. Spring Creek.
Oh, yeah, those are Utah suckers.
Yeah, they're not, because they're very predominant.
Yeah, they are. Yeah, so Utah suckers are closely related to June suckers. Actually, they're apparently pretty decent to eat. The Native Americans ate them a ton, and so did the founding settlers. But they're not they're not really a game fish. Fishing for suckers isn't that fun, I don't think. And so they're actually it's shocking. They're shockingly unregulated by the state of Utah. I believe there's not even a fishing season for them.
They spawn very close to the cutthroat, very close to the kind of the cutthroat.
Yeah, they're spring spawners like a lot of our native species, because that was kind of when we could guarantee that there'd be water for them to survive. Or when they could guarantee for themselves.
Just one more question, this might be for you or might be for just like we have from the white barn coming down with that wood boardwalk, has there ever been a conversation about giving us more access and sort of preserve to kind of see what's going on?
That's not
Is there any, I'm just curious, I
No,
wonder.
it's a great question, and it's one we get a lot, and it's kind of a line we're always trying to walk between protecting those most sensitive places and allowing access so we can see and learn about and enjoy what's out there. The south side of the preserve, where Kimball Creek is, and kind of where Ranch Place is neighbored, most of that is protected by a federal conservation easement that doesn't allow for the development of trails or for open public access. So, we can't just have a straight shot up there across the preserve, unfortunately. Right now, what we're trying to do is just offer a series of hikes and walks and expert-led tours. Every Saturday morning, we have a group that goes out, and so that's what we're doing for now. We do have a total of about 10 miles of trails on the preserve that people can use at any time. And at some point down the road, there is an area where we would love to have a boardwalk, and that's like a $1 million to $2 million project. So it's all back there.
Be interested to fundraise for that and talk about it in the community. I hear a bit of buzz around, what would be great having more access, so wonder if we raise our hand, we could. I'd be on that committee, so.
All right, I'm going to do that.
I raise my hand, here we go.
It would leave from the pier after you do the cemetery.
Are there cutthroat trout over in Kimball Creek or?
So in all my survey this summer, which was probably about 4 to 5 hours of electrical current being run through the stream, I caught one cutthroat trout, which was near the Jewish center up by the other natural Beaver Dam complex. I caught 3 rainbow trout, and I caught hundreds of brown trout. And literally thousands of other fish. I think we caught 9 distinct species, but the cutthroat trout were really practically completely absent. And if you look at kind of the historical monitoring data that Utah Division of Wildlife Resources has, it's kind of sparse, but in the 80s it was about a 50-50 split. In the 90s it was about 25% cutthroat trout. And based on current monitoring, it's about 1% cutthroat trout or less.
I can jump in on that, Marshall, too. I should send you this data, but we did some monitoring in 2008.
Yeah.
And it was similar. We found, we surveyed 2 different stretches on the nature preserve. We found 1 cutthroat.
Yeah.
In each, it was less than 1%.
And I'm kind of new to this, so what's the significance of the cutthroat brown?
Oh, so cutthroat trout is just the native species. Bonnyville cutthroat trout is the native species for the Bonnyville Basin within Utah. And brown trout are not native. People love to fish for them, but they're far from endangered, whereas Bonnyville cutthroats are much more rare and doing much poorer across their range. So it's just a question of
Maybe get brown trout fish them out.
yeah, well, brown trout can outcompete them because they evolved in these really productive, really big rivers in Europe where there was periods of anoxia or periods of low dissolved oxygen, whereas cutthroat trout evolved in rivers and streams within the mountains where they almost never experienced that oxygen limitation. So where cutthroat trout might get super stressed out and not eat for weeks at a time or die, brown trout are able to guide that line and continue on to the good times next year, so to speak.
Do you find that water temperature also has an effect on the ability of cutthroat versus brown?
For sure. Yeah, brown trout are definitely able to withstand much higher temperatures and still maintain like an optimal growth rate. Versus cutthroat trout really need water that's less than about 17 degrees Celsius. I don't know what that is, Fahrenheit, sorry. They need it to be pretty cold in order to maintain their optimal growth rate to really get all of their energy out of their digestion.
Just curious, how did you get started in this field? I mean, was this a childhood?
Yeah. I was always kind of as a kid, I always liked to explore streams and rivers, and I was always really drawn to it. And just kind of slowly as I went through education, I got closer and closer into it. I first started working actually on the Yellowstone River, doing surveys of cottonwoods and figuring out what river migration rates and such were on the Yellowstone. And then after college, I worked a bunch of different jobs, and I just kept coming back to streams. And eventually, I worked in Oregon, which really kicked it off for me. I worked for the Fish and Wildlife Department of Oregon, and we did stream surveys for juvenile salmon, and so we'd go to a different stream every time and go snorkel it and figure out what was living there. And really the beaver sites were the most mind-blowing, because we'd get to a beaver pond and we'd be like, how do we survey this? We can't, there's hundreds of fish and they're flying all around and there's no channel. How do I define what's here? So it was just kind of really influential. And then as I went through time and developed more interests in terms of nutrient cycling and things like that, and groundwater, I just kind of integrated all that slowly into a project. And USC has a really strong history, I guess, of applied research and of beaver research. So when I was looking for grad school, they were on my list, and made some contacts, found some money, ended up here at Swaner.
In East Creek, the nighttime dissolved oxygen content's dropping.
Mm-hmm.
How low does it go, and where would you like it to be?
It's a fair question. It goes low enough that you will literally see fish choke out and die. I should know the parts per million off the top of my head, and I don't. But essentially, I think really Swaner, I should have added this in an alternative slide universe. Swaner Preserve actually does fairly well, where we don't see that many fish kills because of dissolved oxygen within the preserve. However, just down the stream of Swaner, as you start getting towards Generator Ranch Golf Course and such, you see that problem gets larger and larger, right? So if we can use Swaner to be an oxygenation zone, essentially, and export oxygen downstream, rather than just maintaining homeostasis within our stream reach, then we can have a more significant influence on conserving at the population level of East Canyon Creek, and not just the reach level of Swaner Preserve.
If you follow this little creek here and go under the freeway, it seems like the stream on the other side of the freeway is being diverted. Is that from man-made things? Is that beaver?
So there is a really big beaver pond. That natural beaver pond that I showed on the preserve is actually this stream right here. And so as you get right before you get to the mouth of this stream, Spring Creek and East Canyon, right where they merge, that's where this dude actually lives. He lives right down there, and I'm not sure about the diversion that you're talking about. There very well might be a diversion. I mean, there's tons of legacy.
Probably that little guy.
So, it's pretty cool. I haven't actually seen him in real life, aside from in the game tracks, but he's pretty honking beaver. The neighbors told me that he was the biggest beaver they had ever seen.
Yeah, can you talk about where how we got that photo? How we got that photo?
Yeah. I should have mentioned that. So this photo was a game camera, a nighttime and daytime game camera that was set up on the dam itself with the thought that beavers love their dams more than they love their children, so that they would come back to the dam and either crawl over it or fix it or something. And yeah, we got a couple really cool photos and probably even some videos of beaver hanging out there.
Yeah, so they're like motion activated.
Yes. Yeah, and we actually have an assortment of cameras set up right now aimed at our Beaver Dam Analogs that we haven't gone and pulled the SD cards from yet, I don't think. So hopefully we'll be able to see if there is any activity in the area of the Beaver Dams, or the Beaver Dam Analogs, if they're actually helping to build them, we'll be able to get a fast track to them, if you will. Yeah, some information.